In this lesson, we're going to talk about quadratic inequalities. The first method for solving a quadratic inequality is to think about how we would graph the two different equations. So the left side of the inequality and the right side of the inequality. So let's say we want to solve x squared is less than or equal to 9. If I were to graph y equals x squared, we have a parabola that goes to the point 0, 0, the point 1, 1, and the point negative 1, 1. And connecting the dots, we have this U shape. If we graph the line y equals 9, we get a horizontal line, which is graphed in orange. And we are trying to find out when is the graph of y equals 9 bigger than the graph of y equals x squared. So when is the output of 9 bigger? Well, that's in this highlighted region. The orange graph has a larger y value than the black graph in this area. And so we can see that this happens when x is between -3 and 3, and because this inequality was a less than or equal to, we get to include the endpoints. So this graph, or this quadratic inequality, was very straightforward. Let's look at something a little bit more complicated. So when is x squared minus 4x minus 12 greater than or equal to 0? Now when I graph a quadratic equation, I like to use the vertex form, and so I'm going to complete the square. So because we have an x squared minus 4x, to complete the square, I need to add half of -4 and then squared. So I'm going to add a 4, but that changes the value of our equation, and so to balance that out, we're going to subtract 4, and our quadratic expression is x minus 2 quantity squared minus 16. And so we want to graph this. We have a vertex at the point 2, -16. And thinking about transformations, I just see that it's been shifted to the right 2 and down 16. And so we pass through the points 3, -15, and 0. Sorry, 3, -15, and the point 1, -15. We also pass through the point 0, -12, and the point 4, -12. We are comparing our parabola to the line y equals 0, which is our x-axis, and we want to know when is our parabola above the x-axis, and that's in the highlighted regions. So let's find out what the x-intercepts are. And that means we're going to solve x minus 2 squared minus 16 equals 0. We could add 16 to both sides. Then take the square root of both sides. The square root of x minus 2 squared is the absolute value of x minus 2. And so the absolute value of x minus 2 equals 4. So either x minus 2 equals 4 or x minus 2 equals -4, giving us x equals 6 or x equals -2. And so, sorry for that technical difficulty, we found out that our parabola crosses the x-axis at x equals 6 and x equals -2. So I have the points -2, 0 and the point 6, 0. And the graph is above the x-axis when x is less than or equal to -2, or x is bigger than or equal to 6. So there's two different places where the parabola is above the x-axis. So let's do another example. Let's solve x squared plus 2x is less than or equal to x plus 2. If I think about the graph of x squared plus 2x and I complete the square, I know it's x plus 1 quantity squared minus 1. And so it's a parabola with a vertex at the point -1, -1, and it opens up, so it's going to pass through the point 0, 0, and the point -2, 0. The graph of y equals x plus 2 is a line, and it passes through the point 0, 2, and it has a slope of 1. We could see that the graphs intersect at the point -2, 0, or it looks like that in my picture, but to find the exact values where they intersect, we can solve x plus 1 squared minus 1 equals x plus 2. The left side of the equation was actually equal to x squared plus 2x, and that might be easier to work with, so I'm going to replace that. Solving a quadratic equation, we bring everything onto one side. So I'm going to subtract x and subtract 2 from both sides of the equation, and we get x squared plus x minus 2 equals 0. If we could factor, let's factor. And it actually does factor nicely to x plus 2 times x minus 1. And so we find that the two graphs are equal to each other when x equals -2 and when x equals 1. And so I labeled that point up there, that's the point 1, 3. We are trying to find out when our parabola is less than or equal to the line. So when is our orange line bigger than the black parabola? And that happens in the highlighted area. And so we get x squared plus 2x is less than or equal to x plus 2 when x is between -2 and 1. So one thing that may become clear is that depending on how our parabola interacts with our line, we may get one region of answers, like the x between -2 and 1, or like our previous page, we had two areas where the inequality is true. And so we do want to pay attention to whether we get one area or two. So the final two examples we're going to do algebraically and not think about the graphs so much. There's two strategies. We could either factor or we can complete the square. So let's start with factoring. Our first step will be getting all the terms on one side of the inequality and 0 on the other. So we'd have, let's say we have x squared plus 3x minus 10 is less than or equal to 0. We're going to factor this, and it's x plus 5 times x minus 2 is less than or equal to 0. So I have a product of two things being less than or equal to 0. Well, a product is negative when one of the factors is negative and the other factor is positive. And so we get either x plus 5 is greater than or equal to 0 and x minus 2 is less than or equal to 0. So that means the first factor is positive and the second factor is negative. Or it could be that the first factor is negative and the second factor is positive. So now we have four inequalities to solve, kind of. It's really two inequalities. The first one, we get x greater than or equal to -5 and x less than or equal to 2. And on the number line, x bigger than or equal to -5 is shaded. And then we shaded x less than or equal to 2. And because we have the word and, that means we're looking for an overlap, and they overlap from -5 to 2. If I solve the x plus 5 less than or equal to 0 and x minus 2 greater than or equal to 0, we get x less than or equal to negative 5 and x greater than or equal to 2, but this has no overlap, so no solution. So the only time we get a solution is when x is greater than or equal to negative 5 and less than or equal to 2. So our quadratic inequality, x squared plus 3x minus 10 being less than or equal to 0, that's only true when x is between negative 5 and 2. Finally, we will do completing the square. Let's try and solve x squared plus 6x plus 5 greater than or equal to 0. The first step is just to make sure that our x's are together. It doesn't matter where the constant term is. So we're going to be completing the square on the x squared plus 6x. Half of 6 is 3. 3 squared is 9, so we're going to be adding 9 and subtracting 9 to complete the square without changing the value of our expression. The x squared plus 6x plus 9 is a perfect square. It's x plus 3 squared. And then the negative 9 plus 5 simplifies to negative 4. And now we're just going to isolate the x. So adding 4 to both sides of the equation, we get x squared plus 3 squared. X plus 3 squared is greater than or equal to 4. Taking the square root of both sides of the equation, we get the absolute value of x plus 3 is greater than or equal to 2. So now I have an absolute value inequality. When the absolute value is greater than or equal to 2, we get two statements. Either x plus 3 is greater than or equal to 2, or x plus 3 is less than or equal to negative 2. And that means x is greater than or equal to negative 1, or x is less than or equal to negative 5. And this is the word or, so I don't care about overlap. We're just going to take everything involved. If I were to look at the graph of x squared plus 6x plus 5, it's a parabola that opens up. And just giving a rough sketch here. It has an x-intercept at the point negative 1, 0, and another x-intercept at the point negative 5, 0. And so the place where the parabola is above the x-axis, there's two different places, where x is less than or equal to negative 5, or x is bigger than or equal to negative 1. And that's how we solve quadratic inequalities.